Earlier, we were able to help you understand how to prime factor or use prime factorization on a particular number. So now I want to use it in another way that we can find very helpful. Want to add 1/15 plus what plus, or add 1/15 to 7/24. Got to find the lowest common multiple that both 15 and 24 go into. Well, we can skip count for a while. We skip count by 15s. So 15, 30, 45, 60, 75, and so forth. Skip count by 24s, not as easy. 24, 48, what is that, 72, 96, and so forth. And who knows how much longer I need to go, but these numbers are getting awfully heavy. So what we can do instead of skip counting is we can use prime factorizations to help us. So let me explain, let me show you. Remember how to factor tree 15? 15 factor trees down to 3 times a 5. 24 factors down to 4 and a 6. 4 is factored down to a 2 and a 2. They stop. 6 goes down to a 2 and a 3. And 2s and 3s stop. So I have 15 can be written as a 3 times a 5. 24 can be written as a 2 cubed times a 3. Now, we can use this information now to find the least common multiple between the two. In order to do that, I'm going to look at every factor in here and find out where's the most of those exist at. So our first factor, and I usually start lowest to highest, there's a 2. I need as many 2's as is the most that is in either one of those, the most amount. I have 2 to the third here, so I'm going to keep 2 to the third. I know that has to be a factor in my least common multiple. I have 3 here and a 3 here. So my highest degree of 3 in either factor is 3 to the first. My next factor is a 5. No 5's here, but I have a 5 here. I need to have a 5 in my factors to produce my least common multiple. So there I have each of these factors represents the highest degree in either one of my two factor trees. And in doing that, I'm able to help find what my lowest common factor, my least common multiple will be. 2 times 3 times 3, so that's 8 times a 3 times a 5, 8 times a 15. 8 times 15 is 120. So 120 is my least common multiple between 15 and 24. And using a factor tree is usually the easiest way to determine common multiples when the denominators get a little ugly. Of course, you could have kept skip counting. Sooner or later, skip counting by 15s would have got you to 120, and skip counting by 24s would have got you down to 120. Actually, the next one right here would have been 120, and 75, 90, 75, 80, 90, 105, and then there's 120. So skip counting would have got us there. All right, found the least common multiple. What do we do with that? Remember, we use that to help us find an equivalent expression. So 1/15. I know I need to create an equivalent expression that's over 120. So what's the clever version of 1 I'm going to use? 15 times what makes 120? 8 does. So I'm going to create that and turn that into a clever version of 1. 15 times 8 is 120. 1 times 8 is 8. 7/24. Equals 43 over 120ths. Were you able to follow along as we did that process? Did I make a mistake somewhere? Mistakes sometimes happen. There's our final result, and we were able to figure that out by using our prime factorization skills.